In this video, I'm going to show you how to draw parts using the oblique technique. So last few classes, we've been focused on isometric. And isometrics, we can maybe go back a few slides. Isometrics have distinguishing features such as the heights are perfectly up and down. The widths go either top left or bottom right, and that goes at a 30-degree angle. And the depths go also at a 30-degree angle, either to the top right or the bottom left. So these lines over here are all depth lines, like depth line, depth, 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 etc. Height lines are up and down. We can see several height lines throughout, as well as width lines, all of these lines over here. So width, 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 so on and so forth. So that's isometric, a very quick review. And again, we are doing oblique today. And obliques, here are some examples of obliques, not really simple parts, but more complicated oblique drawings. But the biggest thing that jumps off the bat is the obliques have the front face perfectly looking at you, straight on. Notice how the heights over here are up and down, and the widths are not at an angle anymore, but rather along the horizontal. So the vertical lines here are your heights. Your widths are your horizontal on the x-axis. So an oblique pictorial starts with a straight-on view. So it's not at an angle like isometrics, but rather it is straight on. So this is your isometric. That would be your oblique of a similar part. So in this class, I'm actually go back one last slide. The depths go back at a 45-degree angle. So for this, we're no longer going to be using the isometric grid paper, right? We are done with isometric. Well, I shouldn't say we are done. When doing obliques, you would never use isometric grid paper. You only want to use isometric grid paper when you're doing isometrics. When we are doing oblique drawings, we will use regular standard quad grid paper, the vertical and horizontal lines. And they will go back at a 45-degree angle. So there are two types of oblique pictorials. One is called cavalier and one is called cabinet. And they're pretty similar, at least in the beginning, although there is one very big distinguishing difference. And that is how the depth is represented. So you guys, I'm sure, understand about how perspective works, right? Depth perception type thing. And that if you're looking something a little distorted, let me just give you an example actually. If you're looking at a part like this, and you can't really tell how far back that goes if this was an object in the real world, right? If you were looking at a building and the building had a certain depth to it, your brain wouldn't be able to accurately figure out, right? You can't just as simply look at it as if you would look at something straight on and know how much the length is. So obliques try to take that into account. So again, there are two types of oblique pictorials. One is cavalier and one is cabinet. And the difference is, again, the depth. So cavalier will show the depth at its true distance. So if this is 2 units, they would show it written with 2 units in length. However, I think we can all understand that if this has a depth to it, 2 units of length will look smaller than 2 units if it was right in front of you. So what cabinet does is cabinet takes that depth and then it cuts all the depths in half. This is a very, very simple way. If my description on the last slide was a little bit too wordy for you, let's put it in really, really, really simple terms. Here are 2 oblique pictorials. They are of the same object, a cube. The first is cavalier oblique. And that will give you the full height and the full width. However, cavalier will give you the full depth, which you guys should realize might actually be deeper than what it is. Whereas the cabinet will be the same full height and same full width, but it'll only be half of the depth. So this is a little bit closer to how your brain will actually be processing images, although it's only half of the depth. So let's do a summary of the summary, right? Cavalier, full height, full width, full depth. Cabinet, full height, full width, half depth. That's the big kicker right there, is that the cabinets will give you a half of your depth. So how do we draw oblique pictorials? Well, PLTW teaches it using the box method. Like with the isometrics, I'm not a huge fan of the box method, but if it works for you, then it works for you. So you can imagine a glass box around the entire object. So let's show you the pictorial method, right? So you create your glass box. So the overall width is, so it looks like it's 2 units, but they're going to say each one of these boxes is 2. So that'll be 4 as your width. Your overall height will be 6 boxes. And then your depth would be 2. Now, for all of you who know Pythagorean theorem, right? Like if I have this line being 1 and this line being 1, then I think you can all recognize that from corner to corner is actually going to be a little bit more than 1, right? It'd be the square root of 2, like 1.4. I do not expect you guys to be able to just guesstimate that length of 2. So for this class, can we just say that from corner to corner is 1? I think that we can make that assumption. I understand, and I believe that you understand that corner to corner is not truly 1. But for simplicity purposes, let's just call it 1. So if this depth was to be 2, we would go from here to really here. They are doing exact measurements, so we'll roll with it. But when you guys do your examples, we'll do corner to corner being 1 unit. So that's the Cavalier, the overall glass box. And then they will show you that the cabinet has the exact same height and width, exactly the same. The only difference is that their depth is only going to be half when it's cabinet. You will sketch in that front face for both of them, and that would look the same for both examples. The top part as well as the side. Notice how all these lines right here, all these depth lines, are all 45-degree angles. So the heights are on the y-axis, the widths are on the x-axis, and all the depths are from corner to corner at 45-degree angles. Very different than isometrics, which were at 30 degrees in both directions. So all your depth lines are going at 45, and then you are darkening in your object lines. So that's a Cavalier, and cabinet will be the same thing, only all the depths will be half. But notice that the front face is the same for both. Tonal shading is used to help darken things, and that's pretty much it for your intro to oblique drawings.